safe. In C, you can have function pointers, which are a little bit like first-class functions, but not really, in that they are not type safe. But first-class function also means you can do funky tricks like map and reduce. We'll show them later. Types are also first-class, which is something you don't get in C++. That means that every class is an instance of the class, and you can pass it around and can do implement things like factories very easily by just keeping a hash table mapping from like protocol elements in your via protocol to the classes implementing the protocol. You can pull out the class and create an instance of that class without having to say the name, just by having a reference to a type somewhere. Dylan is dynamically typed. That's something, well, most people know the strongly typed versus weakly typed distinction. There's also a statically versus dynamic typed distinction, and it's actually two different things. Lots of people confuse it. Even the Python inventor Van Rossum confuses those things, so it's very common. Dynamic typing basically means that every runtime instance of an object knows its class. Basically, these days you have it anyways. In C++, since you have dynamic types and runtime type information, you have that in your types. It just doesn't feel very dynamic. You have it in Java as well, but again, it doesn't feel that dynamic because you have to specify the types of variables. You don't have to do that in Dylan. It's more feels like a scripting language, like working in Perl or something. You don't have to declare the type of a variable, and the variable doesn't have a type. It's just a binding to an object, and the object has a type. That's what it boils down to. So you write let I equals 23, and you don't care that I is an integer when declaring it. And that leads to you have to work less as a programmer. You have to write less code because you don't have to specify the type for your variables if you don't want to. But you also can make less mistakes. It's less work to change the types in your code. If you look at Windows code, for instance, sometimes the types of variables in the Windows API change, and then you have to go through all your code and change the type specifiers. And some people even use the Hungarian notation, so they have to change the type twice in all their code. And when you refactor your code, it just happens that the type of something changes. And the less changes you have to make to accommodate for that means less work, means less errors you can make. So dynamic typing is a convenience feature for programming, but it's also a feature of dynamism in your code. If you write in a statically typed language, you often start to emulate dynamic typing features by remembering some type information somewhere and then manually checking it. You usually notice in your C or C++ code when you start to pass around void pointers and then cast them back to some type that you really miss dynamic typing and want to have it. And it's Dylan does it the other way around. Metaprogramming is something here. I'm not sure if many people have heard it. It's metaprogramming or domain-specific languages. Basically, the idea is that you can change the grammar of your language to better accommodate your problem. We'll have an example for that later as well. So in order to work less, you describe the problem in a problem-specific language, and the programming language gives you a tool to change the language so you can develop your own language for describing problems. This comes in the form of macros. At the moment, Dylan macros work, well, they resemble C++ templates in a way, and that they don't work on text substitution, but they work on substitution on the parse tree. Or you can also say it adds productions to the grammar, so you can write your own if statement or your own while statement if you want to, or your own class declaration. That's metaprogramming. The last one is very interesting, optimistic type inferencing. If you've ever done any programming in ML or other statically typed functional languages, you probably know about type inferencing. It's that the compiler looks at your code and figures out the type of an expression. So if you write 3 plus 3, compiler knows, oh, I have a function called plus, the arguments are 3 and 3. I know that 3 is an integer, so I know that adding 2 integers will produce an integer as well. So the type of the expression 3 plus 3 must be an integer too. And what happens at that place in Dylan is that the compiler tries to do that for all as long as it can. So at some point you might have a completely dynamic case, like when the type of an object completely depends on user input, the compiler can't know it. But it tries to figure out the type of expressions at compile time and uses that information to optimize away stuff like type checks, stuff like function dispatch, and that's really where the high performance code comes from. So you can write your dynamic code and it won't be very fast, but you tie down your types a little here and a little there, and the compiler can predict a lot of things. And suddenly you have a fast program. That's also something you cannot do in C++. You cannot optimize away a vtable dispatch in C++. And basically Dylan can do that. Yeah, there were 3 implementations, I already mentioned that. Apple Dylan is basically dead. Apple had bad times in 1996. This was a very, very cool programming environment, and I was completely hooked. It was interactive. You could click on the features you have in Eclipse these days. Those guys had that 10 years back, including clicking on everything, including the debugger, and then ending up in the assembly of a function, and then going back from there into the source code. And interactive code execution, everything. It's a shame this is gone. Then there was the Carnegie Mellon project. It's a Dylan to C compiler written in Dylan. And it's basically a batch compiler, so it doesn't have a lot of the power you really want from your environment, like interactive code executions, debuggers. But still, it's there, it's open source, and it's being maintained. And it's highly portable and generates efficient code. And it's something to play with. The third one, Harlequin, this one is very interesting because the folks who did that really have a lot of experience. You might have heard about Lisp machines. After Symbolics, the last Lisp machine vendor, went bankrupt, those people went to Harlequin. And so the people who worked on that compiler really, really knew their stuff. It's the people who wrote the Emacs or Emacs clone for the Lisp machine, the compilers for the Lisp machine, the garbage collectors there. It's a Dylan compiler which compiles native x86 code. And it's got an IDE, it's got a debugger, it's got a profiler. It's got interactive code execution, so you can type little lines of code and try it out with the code base. It got hot code updates, so if you run into a bug, you can fix the bug and upload the changed function into your running executable. Try it out again. And it used to be a commercial project and really was a big investment. And Harlequin also went bankrupt for various reasons. They have not only been doing programming languages, but they also did intelligence software and PostScript rasterizer software, and it was a big mess, and so they went bankrupt. A lot of parts were bought. The Dylan compiler was bought by the programmers who wrote it because no other commercial entity wanted it. And we're in the very lucky situation that those people finally decided to open up all the source code as open source. And we have, it must be hundreds of person years into that code, about 1 million lines of code in our repository, which are now open source. It's so much code that with the 5 or 6 people in the maintenance project, we didn't even get around trying to compile all of the libraries which are there, and it's really a lot. And yeah, that's what we have been using, that's what we want to develop further. And basically, that's the powerful tool we want to have for our programming language. That's a little glimpse into the libraries which are there. So you have user interface, networking, regular expressions, persistent object stores, XML parsers, database interfaces, web server, mail server code, and probably lots of stuff we don't even know it's there. Dwim is an interesting point. If you ever done Common Lisp, you probably know Clim, the Common Lisp interface manager. And Dwim is done by the same person who did Clim before. So it's basically second generation Clim with most of the features of that. Yeah, that's finally a glimpse of Dylan code. After talking about all that, we're actually going to show you some code. So it has an algo-like syntax. It looks a little bit like Pascal, if you're used to that. Some people say that it's a little verbose, but the only thing really verbose about it, if you compare it to other languages, is that you have to write end. The alternative would have been doing the Python approach of using indentation instead of begin and end, or maybe another set of braces instead of begin and end, but in the end it doesn't really matter because I type fast enough so it isn't a problem. And if you have 2 or 3 pages of code in a function, you actually start to appreciate that there's something at the end of a code block that's not just a void space and you have to guess where it ends and go up 2 pages and look for the beginning, go down again. So I think it's okay. Dylan comes with a lot of flexibility in choosing names for identifiers. So for instance, it allows dashes in identifiers, which really makes the code much easier to read because usually you start to use underscores and it's straining on the eyes to use underscores, and it's much easier to read with a dash in the middle. There are some naming conventions like using angle brackets around type names or asterisks around global variables, predicate functions and in question marks, etc. These are all only conventions. It's not part of the syntax. Yep, dynamically and strongly typed. It's, I already mentioned that it's very important to distinguish the two. Strong versus weak typing basically just means that in a strongly typed language, you don't have a way to work around the type system of your language. You cannot pretend some object, some integer is a pointer or something like that. So in a strongly typed language, lots of security relevant bugs just can't happen. Whereas in a weakly typed language, you can use a cast and cast around, or maybe just do an addition and it will magically cast behind your back. So Dylan is strongly typed in the sense that you cannot circumvent the typing system, but it's dynamically typed, and that runtime instances of objects have types, and bindings, what other people would call variables, don't have types or don't necessarily have types. So it feels like a scripting language in typing aspects, basically. I already mentioned the object system as well. It's class-based. The opposite of class-based would be prototype-based, like done in JavaScript, which stole the idea from a language called Self. So in Dylan you have classes, and every object is an instance of a class. And that's what a class definition looks like. There is a lot of syntactic sugar in such a class definition, but the point in that is that you usually don't have to write a constructor. You get around writing a constructor because all the usual cases are already covered. You see there's a square which inherits from a class rectangle, and what C++ would call a member, or other languages would call a field, is here called a slot. And there is a type declaration for the slot named x, which is of type number. So the 2 colons say here's a type. This is one, the type is actually optional. You don't have to write it. If you do write it, the compiler will check the type for you. So it does a type check on